Welcome to True Projects. In this video, we are going to explain about the project, which is mining weak relations between reviews for opinion spam detection. Introduction of the project. With the rise of e-commerce, consumers increasingly rely on online reviews to inform their purchase decisions. However, the convenience of user-generated reviews is marred by the presence of opinion spammers who flood review platforms with the deceptive content for financial gain. Opinion spammers motivated by financial incentives create a significant volume of deceptive reviews, misleading consumers and adversely affecting online commerce. Instances of companies hiring individuals to post positive or negative reviews for further exemplifying the challenges posed by opinion spam. Current methods for detecting opinion spam primarily focus on linguistic or behavioral features, often manually constructed by experts. However, these methods struggle to capture semantic information effectively, prompting exploration into advanced techniques including deep learning to automatically learn nuanced features. Inspired by the success of deep learning in capturing semantic information, advanced methods have been proposed to learn representations of users, reviews, and products. These methods aim to exploit strong relations but often overlook weak relations between reviews, making the detection of spammers more challenging. Weak relations exemplified by latent connections between reviews based on factors such as release time and ratings provide crucial information for detecting opinion spams. The illustration of strong and weak relations in a real-world example emphasizes the need to consider both types of relations for a comprehensive opinion spam detection mode. Objective of the project. The primary aim of this project is to develop a robust model dedicated to the accurate identification of opinion spam within the reviews. The overarching objective is to create a classifier capable of predicting whether a given review is authorized by a spammer. The project aims to establish a model characterized by a dual component structure featuring the graph construction level and the feature fusion level. The goal is to construct multi-level weak relation graphs that capture non-semantic information and mitigate the dominant influence of majority classes. Additionally, the project aims to leverage graph convolutional network, which are GCNs, to encode review information and strong relations. One of the primary objectives is to implement a relation-level attention mechanism within the weak-strong unified network, which is WSUNet. The mechanism is designed to amalgamate information from different levels, content, sentiment, and temporal. The ultimate aim is to enable the model to assign varying importance to diverse features, refining the representation of reviews for non-spam detection. The project aims to extract linguistic features from reviewers and product-related features to harness the user review product strong relation. Furthermore, the objective is to apply a relation-level attention mechanism to capture the most effective features on the obtained embeddings. The overarching goal is to ensure comprehensive and informative representations, enhancing the model's capability for improved spam detection. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. To implement this project, we have designed various modules in the flow of work. So the first module is importing the packages. This step involves importing necessary Python packages and libraries. We have imported NumPy for numerical operation, Pandas for data manipulation, Scikit-learn for machine learning, TensorFlow for deep learning, and Flask for web framework. The next module is exploring the dataset. The project involves working with the multiple datasets including Yelp NYC, Yelp Zip, mobile review, hotel and restaurant review. Exploring these datasets is crucial to understand the characteristics of the data such as structure, size, and features. The next module is visualization. Visualization techniques are applied to gain insights into the data. This includes generating plots and graphs to visualize distributions, patterns, or trends in the reviews, providing a better understanding of the dataset. The next module is data processing. The raw data is pre-processed to enhance its suitability for model training. Here we remove URLs and special characteristics to clean the data, which is text data, from any irrelevant information. We remove punctuations to eliminate unnecessary punctuation marks. We remove stoppwords, which are common words that may not contribute much to analysis, are removed to focus on meaningful content. The next module is tokenization. The process of breaking down text into smaller units or tokens is performed using various techniques. The techniques are count vectorizer. It converts text into bag of words representation. Coming to Keras tokenizer. Tokenizer text using Keras. It is a popular deep learning library. Coming to BERT tokenizer. It utilizes BERT, which is bidirectional encoder representations from transformers for contextualized tokenization. Coming to Torch text. It is a library for processing natural language data often used in combination with PyTorch. The next module is feature selection. Techniques are employed to select relevant features for model training, ensuring that model learns from the most informative aspects of the data. The next module is splitting the data into train and test. The dataset is divided into training and testing sets. The training set is used to train the model, while the testing set is used to evaluate the model's performance on unseen dataset. The next module is building the data. Building the model. The architecture and design of the model are defined in this step. This involves constructing a machine learning model for prediction. The next module is training the model. The model is trained on the training set, which is dataset. During training, the model learns to make predictions based on the input features and corresponding labels, which are spam or not spam. As an extension, we applied an ensemble method that combines the predictions of multiple individual models to produce more robust and accurate final prediction. As an extension, we built the front end using Flask framework for user testing with user authentication. The next module is Flask framework with SQLite for sign up and sign in. Flask, a web framework, is used to create a web application. SQLite is employed as a lightweight database for user authentication, allowing users to sign up and sign into the system. The next module is user gives input. User interact with the application by providing input in the form of text for analysis. The next module is pre-processing the given input for prediction. The input from users undergoes pre-processing steps similar to those applied to the training data, ensuring the consistency and compatibility with the model. The next module is trained model is used for prediction. The pre-processed input is fed into the trained model for prediction. The model outputs a classification indicating whether the given input is likely to be spam or not spam. The next module is along with that we applied LDA model for topic modeling. Latent right-click allocation is a probabilistic model used for topic modeling. It is applied to identify topics within the text data, providing additional insights beyond spam detection. Coming to the last module, which is final outcome, is displayed through frontend. The final results, including the prediction from the trained model and topics identified by LDA, are displayed to the user through the web frontend of the application. This step ensures a user-friendly experience and effective communication of the analysis outcomes. Algorithms which are used in this project are support vector machine using label fusion. It is a powerful supervised learning algorithm for classification and regression tasks. Label fusion involves combining information from different sources or modalities to enhance the classification performance. In opinion spam detection, SVM can effectively separate spam and non-spam instances by finding an optimal hyperplane in a high-dimensional feature space. Coming to support vector machine using label fusion and random forest, combining SVM with the random forest aims to leverage the strengths of both algorithms. SVM excels in finding complex decision boundaries, while random forest is an ensemble method that can handle diverse features and reduce overfitting. This combination leads to a more robust model for opinion spam detection. The next algorithm is combination of convolutional neural network with generalized regression neural network. A CNN is adept at capturing spatial relationships in data, often used in image processing, while a GRNN is designed for regression tasks, effectively handling non-linear relationships. In opinion spam detection, the combination leverage CNN for feature extraction from review content and GRNN for predicting non-spam probabilities. Coming to sliding window neural network, it involves a neural network architecture designed to process sequential data with sliding windows. In opinion spam detection, this approach can capture temporal patterns and dependencies within reviews, allowing the model to consider the evolving nature of user opinions. The next model is attention-based neural network, which is ABNN. It incorporates attention mechanisms, enabling the model to focus on specific parts of the input sequence. In opinion spam detection, this can be beneficial for giving more weight to crucial features or words in reviews. enhancing the model's ability to identify spam-related patterns. The next algorithm is Hierarchical Fuzzy Adaptive Network, which is HFAN. It employs a hierarchical and fuzzy logic-based approach to adaptively handle uncertain information. In opinion spam detection, this can be advantageous for addressing the ambiguity and uncertainty often present in user-generated reviews. The next algorithm is Adaptive Ensemble Data Augmentation, which is AEDA. It involves dynamically adjusting an ensemble model based on incoming data. This adaptability can be valuable in opinion spam detection, where the nature of the spam may evolve over time. AEDA helps the model to stay effective in the face of changing patterns. Coming to bidirectional encoder representations from transformers, which is BERT. It is a transformer-based language model known for its contextual understanding of natural language. In opinion spam detection, BERT can capture complex relationships and context of review text, enabling the model to discern subtle nuances and dependencies in the language. The next model is Graph Attention Network, which is Graph Convolutional Networks. They are tailored for graph structured data. In opinion spam detection, using GCNs implies models the relationships between users, reviews, and products as a graph. This allows the model to capture intricate connections and dependencies in the data, improving the understanding of the review ecosystem. The next algorithm is Weak Strong Unified Network, which is WSUN. It integrates weak and strong relations into a unified framework. In the context of opinion spam detection, this involves leveraging both subtle weak connections, which are such as temporal patterns, and strong connections such as user-product relations to create a more comprehensive and robust model. We have evaluated this project using different classification metrics, which are accuracy, precision, recall, and F1 score. So here we have comparison graphs for Amazon dataset, which is mobile reviews dataset. This is the accuracy comparison graph. Here we have on x-axis accuracy score for each algorithm, and on y-axis we have algorithm names. Accuracy is a metric used to measure the overall correctness of a classification model. It is defined as the ratio of correctly predicted instances to the total number of instances in the dataset. This is the precision score comparison graph. X-axis represents precision score for each algorithm, and on y-axis we have algorithm names. Precision is a metric that quantifies the accuracy of positive predictions made by a model. It is defined as the ratio of true positive predictions to the total number of positive predictions. This is the recall score comparison graph, where x-axis represents recall score for each algorithm, and on y-axis we have algorithm names. Recall is also known as sensitivity or true positivity. It measures the model's ability to correctly identify all relevant instances in the dataset. It is defined as the ratio of true positive predictions to the total number of actual positive instances. This is the F-score comparison graph, where on x-axis we have F1 score for each algorithm, and on y-axis we have algorithm names. This is a metric that combines both precision and recall into a single value, providing a balance between them. It is the harmonic mean of precision and recall, and it is particularly useful when we want to strike a balance between minimizing false positives and false negatives. Here we have comparison graphs for hotel and restaurant review dataset. These are the comparison graphs for Yelp NYC dataset. These are the comparison graphs for Yelp Zip dataset. The algorithm which performs well in all these metrics will be used for the prediction. To execute this project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Here we have templates folder. This folder consists of files related to HTML pages. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the signup file. This file is a database file used to store the user information. Now to execute the project, first we need to copy the code folder, code folder path from the address bar of the File Explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command, we need to paste the copied path and then click on enter. This will change the current directory to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. This is the localhost and this is the port, and let's configure differently. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First we need to click on it and enter all the sign up details if you are signing up new. I have already signed up and I have an account in it, so we'll directly click on sign in now. Here we need to provide our username and the password to log in. Now we need to click on login. Our login is successful. So here we can see a text box. First we need to enter the message in that text box. Based on the given message, the system will predict whether the message is spam or not spam. Here in the notepad we have some of the test cases on which we will do the prediction. So I'm copying the first text. Here we will paste the message and then click on predict. So it is predicted that the message is ham content, which means the message is not spam. Now we will paste one more text and see what will be predicted. We will copy the 15th text and paste it here and click on predict. It is predicted that the message is spam content. Now we will give one more message and see what will be predicted. Now we will copy the 11th message. Here we will paste it and click on predict. It is predicted that the message is ham content, which means it is not spam. In this way, if we give the input message to the system, then the system will predict whether the message is spam or not spam. Conclusion of the project. The project successfully developed a robust opinion spam detection model utilizing a diverse set of algorithms including SVM, CNN and BERT. This ensures a comprehensive approach to identifying spam in user-generated reviews. Through the application of various tokenization techniques such as Count Vectorizer, Keras Tokenizer and BERT Tokenizer, the project demonstrated effective feature extraction, enabling the model to understand, process textual data and more comprehensively. The use of graph attention networks highlighted the project's emphasis on capturing intricate relationships and dependencies in the data. This graph-based approach, particularly in model user-product relations, contributes to a more nuanced understanding of the review ecosystem. Integration with the Flask framework, coupled with the SQLite for user authentication, ensures a user-friendly experience. The ability for users to sign up and sign in enhances the overall usability and accessibility of the opinion spam detection system. The incorporation of latent triglet allocation for topic modeling provides an additional layer of interpretability. This feature enables the identification of underlying themes or topics within the reviews, contributing to a richer understanding of the content beyond spam detection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.